Hello friends, myself is Pawar A from sgm College Kadar. In last lecture, we discussed the point which is increasing and decreasing function. Now in this lecture, we discuss the new point which is maxima and minima. It is a very important point for this chapter because in board exam, 3 to 4 marks question asking for this point. So let's start our new point which is maxima and minima. When your function f of x is given and we can find the maximum value and minimum value, that time we use this concept. So first we see here maxima of a function f of x. Here a function f of x is said to have a maximum at x is equal to c if the value of the function at x is equal to c is greater than any other value of a f of x in a delta neighborhood of c, that is for a small delta is greater than 0 and for x belongs to open interval c minus delta comma c plus delta, we have f of c is greater than f of x. The value of f of c is called a maximum of f of x. Thus, the function f of x will have maximum at x is equal to c if f of x is increasing in c minus delta is less than x is less than c and decreasing in c less than x is less than c plus delta. So this is the definition of maximum of a function. Now next we see here minimum of a function f of x. So here a function f of x is said to have a minimum at x is equal to c if the value of the function at x is equal to c is less than any other value of f of x in a delta neighborhood of c, that is for a small delta is greater than 0 and for x belongs to open interval c comma delta c minus delta comma c plus delta, we have f of c is less than f of x, then the value of f of c is called minimum of f of x. Thus the function f of c will have minimum at x is equal to c if f of x is decreasing in c minus delta is less than x is less than c and increasing in c is less than x is less than c plus delta. So this is the definition of minimum of a function. Now how to find minimum and maximum function? There is a two test. So first we see first derivative test. So there is some steps we can find maximum and minimum by using first derivative test. So our first step is find f dash of x. Second step, find the root of equation f dash of x is equal to 0. Third, if c is the root of this equation, means which equation? This equation, then find f dash of c minus h and f dash of c plus h, where h is a very small positive real number. Now next here, if f dash of c minus h is greater than 0 and f dash of c plus h is less than 0, then f has a maximum at x is equal to c. Second, if f dash of c minus h is less than 0 and f dash of c plus h is greater than 0, then f has a minimum at x is equal to c. Means when you find these two terms, we can check here it is a greater than or it is a less than, then f has a maximum at x is equal to c. And if this is a less than and this is a greater than, then f has a minimum at x is equal to c. Fourth step, use the same procedure for other roots of f dash of x is equal to 0 as in 3. So same procedure we can apply when your roots, second roots for f dash of x. So this is our first derivative test. Now we can see here second derivative test. Again here some steps. So our first step is find f dash of x and f double dash of x. Second, find the root of equation then find f dash of x is equal to 0. Second, if c is a root of this equation, find f double dash of c. Means first we find f dash of x, second we find f double dash of x, then we find root of equation when this term is equal to 0. When if c is a root of this equation, then find f double dash of c. Now here, if f double dash of c is less than 0, then f has a maximum at x is equal to c. Second, if f double dash of c is greater than 0, then f has a minimum at x is equal to c. Now fourth step, use the same procedure for other roots of f dash of x as in 3. So this is the second derivative test. Now when you find maximum and minimum of function, that type we use most convenient for second derivative test. So whenever we solve the examples for maxima and minima, we can use most your test, which is a second derivative test. Now we can see here note. Our first note is if second derivative test fails, that is f double dash of x c is equal to 0, then we have to apply first derivative test. Means when your second derivative test is failed, means f double dash of c is equal to 0, then we have to apply first derivative test. And next, if first derivative test also fails, then x is equal to c is neither point of local maxima nor point of local minima. So it is called as a point of inflection. So when your first derivative test is also failed, then at x is equal to c is a point is called as a point of inflection. So this is very important note for CET. Now we can solve some examples depends on maxima and minima by using second derivative test. So let's start. Example based on the maxima and minima. So example, find the maximum and minimum of the following function. Our first function is f of x is equal to 5x cube plus 2x square minus 3x. Now we can apply second derivative test, find the maximum and minimum value. So let's start the solution. Here f of x is equal to 5x cube plus 2x square minus 3x. Now differentiate with respect to x first. So f dash of x is equal to 5x square plus 15x square plus 4x minus 3. Now again I differentiate with respect to x. We get here f double dash of x is equal to 30x plus 4. Now we can find here roots of equation f dash of x is equal to 0. So here for extreme values, comma, f dash of x is equal to 0, it gives 15x square plus 4x minus 3 is equal to 0. Now we can find roots of this equation. That means we can factorize this equation. Find those two numbers, which is multiplication is minus 45 and addition subtraction is plus 4. So number is 9x and 5x. So we can find this, split this number in such a way, 15x square plus 9x minus 5x minus 3 is equal to 0. Now in this term, 3x is common, take it outside. So therefore 3x inside the bracket, 5x plus 3, bracket complete. In this term, minus 1, take it outside, inside the bracket, 5x plus 3, bracket complete, is equal to 0. Now in this term, 5x plus 3 is common, take it outside. So we get here, therefore 3x minus 1 multiply 5x plus 3 is equal to 0. Now we get here x is equal to 1 by 3 or x is equal to minus 3 by 5. So this is the root of this equation. So next, here the roots of f dash of x is equal to 0 are x1 is equal to 1 by 3 and x2 is equal to minus 3 by 5. Now we can use next step, we can find f double dash of c. So f double dash of 1 by 3, whenever is x replaced by 1 by 3, so 30 multiply 1 by 3 plus 4. Now simplify this, we get here plus 14 which is greater than 0. So by second derivative test, f of x is minimum at x is equal to 1 by 3 and the minimum value of f of x at x is equal to 1 by 3 is f of x is equal to 5x cube plus 2x square minus 3x. Whenever is x replaced by 1 by 3, so f of x 1 by 3 is equal to 5 multiply 1 by 3 whole cube plus 2 multiply 1 by 3 whole square minus 3 multiply 1 by 3. Simplify this, we get here 5 divided by 27 plus 2 divided by 9 minus 1. Again simplify. So we get here f of 1 by 3 is equal to minus 16 by 27. So it is a minimum value at x is equal to 1 by 3. Now same procedure we can apply by second root. So we can find f double dash of minus 3 by 5. So f double dash of minus 3 by 5 is equal to 30 multiply minus 3 by 5 plus 4. Simplify this, we get here minus 14 which is less than 0. So by second derivative test, f of x is a maximum at x is equal to minus 3 by 5 and maximum value of f of x at x is equal to minus 3 by 5 is f of x is equal to 5x cube plus 2x square minus 3x. Whenever is x replaced by minus 3 by 5. So f of x is equal to minus 3 by 5 is equal to 5 multiply minus 3 by 5 whole cube plus 2 multiply minus 3 by 5 whole square minus 3 multiply minus 3 by 5. Now simplify this, we get here to minus 27 upon 25 plus 18 upon 25 plus 9 upon 5. Now again simplify this, we get here f of minus 3 by 5 is equal to 36 upon 25. Hence, the function f has maximum value 36 upon 25 at x is equal to minus 3 by 5 and minimum value minus 16 upon 27 at x is equal to 1 by 3. So this is our final answer. Now next example, f of x is equal to x cube minus 9x square plus 24x. So again we can find maximum and minimum value by using a second derivative test. So simplify this. So solution given f of x is equal to x cube minus 9x square plus 24x. Now first we find first derivative. So f dash of x is equal to 3x square minus 18x plus 24. Again differentiate with respect to x. So f double dash of x is equal to 6x minus 18. Now we can find the root of this equation when f dash of x is equal to 0. So find for extreme value f dash of x is equal to 0. It gives 3x square minus 18x plus 24 is equal to 0. Now in this term is 3 is common, take it outside. So inside the bracket, therefore 3 inside the bracket x square minus 6x plus 8 bracket complete is equal to 0. Now product of this number is 0, that means 3 is not equal to 0, that means x square minus 6x plus 8 is equal to 0. Now find the factor of this equation. So find those two numbers which is multiplication is 8 and addition subtraction is minus 6. So x square minus 4x minus 2x plus 8 is equal to 0. Now in this term x is common, take it outside. So inside the bracket x minus 4. In this term minus 2 is common, take it outside. Inside the bracket x minus 4 is equal to 0. Now x minus 4 is common, take it outside. So therefore x minus 4 multiply x minus 2 is equal to 0. So this gives x is equal to 4 or x is equal to 2. So therefore the roots of f dash of x is equal to 0 are x1 is equal to 4 and x2 is equal to 2. So this is the roots of f dash of x is equal to 0. Now our next step is we can find f double dash of c. So first we put x1 is equal to 4 and next we put x2 is equal to 2. So f double dash of 4. Whenever is x replaced by 4, so 6 multiply 4 minus 18. Simplify this, we get here 6 which is greater than 0. So by the second derivative test, f of x is a minimum at x is equal to 4 and minimum value of f of x at x is equal to 4 is f of x is x cube minus 9x square plus 24 multiply x. Now whenever is x replaced by 4, so f of 4 is equal to 4 cube minus 9 multiply 4 square plus 24 multiply 4. Now simplify this, So f of 4 is equal to 64 minus 144 plus 96. Again simplify this. So f of 4 is equal to 16. So this is the minimum value at x is equal to 4. Now same procedure we can use by another root. So b f of f double dash of 2. Whenever is x replaced by 2. So 6 multiplied 2 minus 18. So we get here minus 6 which is less than 0. So by second derivative test, f of x is maximum at x is equal to 2 and maximum value of f of x at x is equal to 2 is, whenever is x replaced by 2, so f of x is equal to x cube minus 9x square plus 24x. Now whenever is x replaced by 2, so f of 2 is equal to 2 cube minus 9 multiplied 2 square plus 24 multiplied 2. Now simplify this. So f of 2 is equal to 8 minus 36 plus 48. So f of 2 is equal to 20. So this is the maximum value at x is equal to 2. So hence the function f has maximum value 20 at x is equal to 2 and minimum value 60 at x is equal to 4. So this is our final answer. Now next example, f of x is equal to x log of x. Now again we can use a second derivative test. So first we find the first derivative, second we find the second derivative. So let's start the solution. Given f of x is equal to x log of x. Now differentiate with respect to x by using u multiply v rule. So the f dash of x is equal to you use here u multiply v rule. So x derivative of log of x with respect to x plus log of x as it is derivative of x with respect to x. We know that derivative of log of x which is 1 upon x and derivative of x which is 1. So f dash of x is equal to x multiply 1 by x plus log of x multiply 1. So f dash of x is equal to 1 plus log of x. Now again differentiate with respect to x. Derivative of this term is 0 and derivative of log x which is 1 upon x. So f double dash of x is equal to 1 by x. So first we find f dash of x and second we find f double dash of x. Now we can find roots of f dash of x is equal to 0. So for extreme value f dash of x is equal to 0, it gives 1 plus log of x is equal to 0. Now this one goes that side is minus. So log of x is equal to minus 1. Now in this term here log and here only number. So this number convert into log term. So we can apply here. Therefore log of x is equal to minus log of e. Because here base is e. So we know that log of e to the base e, answer is 1. So next we can apply here law of exponent. So whatever number here, whatever term here goes to the reciprocal. So we get goes to the power of this e. So therefore log of x is equal to log of e raised to minus 1. So if two logs are same, then corresponding number are same. So therefore x is equal to e raised to minus 1. That means x is equal to 1 upon e. So we get here only one root which is x is equal to 1 by e. Now we can apply this next procedure. We can put this root in f double dash of x. So now the root of f dash of x is equal to 0 is x1 is equal to 1 by a. Now this value put in f double dash of x. So when x1 is equal to 1 by e, so f double dash of 1 by x1 is equal to 1 upon x. So whenever is x replaced by 1 by e, so 1 upon 1 by e. Now we get here e and we know that e value is 2.72. So it which is a greater than 0. So by second derivative test, f is a minimum at x is equal to 1 by e and minimum value of f of x at x is equal to 1 by e is. Now f of x is equal to x log of x. Whenever is x replaced by 1 by e, so f of 1 by e is equal to 1 by e multiply log of 1 by e. Now this we can write e raised to minus 1. So f of 1 by e is equal to 1 by e multiply log of e raised to minus 1. Now we can apply here law of exponent whatever power taking front. So f of 1 by e is equal to 1 by e multiply minus 1 multiply log of e. We know that log of e to the base e, answer is 1. So f of 1 by e is equal to minus 1 upon e. So this is minimum value at x is equal to 1 by e. So hence function has minimum value minus 1 by e at x is equal to 1 by e. So this is our final, this is our last example for this lecture. Next lecture we can solve some more example which is depends on maxima and minima. Thank you.